So some of you may have used, if you've taken, let's say, Math 3 or inside your one of your algebraic classes, you may have worked with matrices. It is typically a topic, at least within our school, that I've seen that it is often a topic that um, is pulled from some of the curriculums just because we can't cover it. Something has to go. It's usually one of the things that does. Um, Matrices have a very are very important, especially in the form of linear algebra and um, in ideas like discrete mathematics and graph theory. In high school, we rarely do cover those type of topics, though, especially linear algebra. It's typically a college-based course, and with linear algebra, of course, discrete mathematics, which is our course. I'm going to try to keep the amount of actual mathematics that we'll have to utilize that's advanced down for the use of matrices. I want you to be able to understand how they're used, though. They are very important, and especially at least in the relationship to how they are used to describe these network graphs can be very useful for us. So, based on a review from yesterday, we can draw a network graph. Uh, okay, and I'll label this A, B, C, D, and E. And you'll see on your homework in tonight's homework, the problems are the same network graph. The network graphs in tonight's problems are the same network graphs that were on yesterday's problems. That was done purposely because the way you're writing them is different. Yesterday you wrote them as sets. Today we're going to write them as matrices. And in terms of the edges, we'll go with here, 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 here. We'll go with something like this. So A and B or A and B are friends. So B, we're talking about friends here. It could be any type of social networking, Instagram, Snapchat, Facebook. So A and B are friends. All right. Um, so B is friends with only one person within the network, and that's person A. A is friends with B, D, and E, very friendly. E is friends with A and C. C is friends with E and D. D is friends with A and C. So if B wants to talk to C, and we'll talk about this in next week, B would have to talk to A, then talk to D, and then finally reach to C. And that's one of the ideas that we're gonna actually work with in terms of finding, in terms of what is like the shortest way that B can talk to C, just to give you a preview of what we're gonna start trying to calculate and find next week. And we'll also talk about directed graphs as well. So we got a lot of stuff. We got directed graphs, then we'll add some weights onto the edges, what we call them right now. Basically, A and B are everybody's just a normal friend. Then you have those like close friends, right? You have friends, and then you have close friends, and so we're talking about driving down, driving down the streets of Boston, and so some streets you can, there's never any traffic, and so it's very fast to get there. It only takes you 5 minutes. But then other streets, in going from one to another one, it might take you, 20 minutes. And so one of the edges will be worth 5 and the other edge will be worth 20. And then we'll talk about, sometimes just, how do we get from one to another? And of course, how long does it take? So some real good stuff that we can do with network graph. Like I said, I haven't done this type of stuff since I was in college. Um, and I remember very fondly of it in terms of the applications. I learned about it a little too late in my college career, actually, to tell you the truth, because I probably even would have went into a degree in this type of material, but sadly, I didn't cover this until like my junior year of college, and I was already on my road for diploma. So in question A, we're going to describe the network graph using sets. Can I get somebody to help me out with this one? Review from last night.
Do we first have to like number them like A, B, C, D?
They are.
How do I put it on? First, to open brackets, you put A, B.
Well, what are you trying to describe? What are you trying to describe?
Sets.
No, but what are you describing right now? What are you listing?
I forgot.
You're right. You're right in what you're trying to do, but what are you trying to list? So this is all about lists. Sets and lists are the same idea. So what are you trying to list? What are those representing?
Give me a second. Vertices.
Very good. So the vertices are, that's where you're talking about the open brace. Very good. And you said A, B, C, D, and E. And now we need to do what? If we're not done yet.
I forgot to mute me. Edges. I said edges.
Edges. And what are the edges? Somebody else can speak up. Somebody else can help as well.
AB. The lines that
AB.
connect the points.
AB.
AE.
I'm going to try to stay in the letters. So AD and AE. Doesn't matter the order in which you write them. But it's in terms of making sure that you cover each one of them. I always recommend that you choose one of the vertices and knock out all of those so that you don't use those anymore. You can also utilize things like, all right, I've already covered that one, and that one. So making sure that you don't miss any.
DC. Wait, I have a cool question. Does DA count as one?
We've already used DA. Because DA and AD are the same thing.
DE?
And DE. And that's it. So right now we're talking about, like I said, we're talking about undirected. So in, like I said, right now you can go from A to B or B to A. So A talks to B and B talks to A. So they go. It's a two-way street. So when we signify that by using the braces in discrete in these descriptions. And as such, if we were to write AE or EA, they are the exact same thing. You would be marked down in a sense if you wrote both of them. So if you try to write them in both directions. So you should count the edges. We have 1, 2, 3, 4, 5 edges. And so 1, 2, 3, 4, 5 edges, and 1, 2, 3, 4, 5 edges described. Now, so that was yesterday. That's what you did in your homework yesterday. So we're going to learn a new way to write these, and this is called, and we're going to come back and use this a little bit. These are called, it is called an adjacency matrix. Matrices for plural. So an adjacency matrix shows the connections directed and undirected. And so we'll talk about how we utilize them for directed next week, but I just want to put that in there. Between vertices. Of course, nodes, also known as nodes. One is equal to a connection. 0 equals, so which is means that there's an edge between, and 0 equals no connection, no edge between. Since our current graphs are undirected, we mirror the values across rows and columns. Eventually, we will add weights to edges, to connections, values other than 1, but not now. So all you have to work on and focus on right now is just ones and zeros. All right, we call this binary, and we will get into the materials of binary either in discrete math or maybe in the follow-up course. We'll talk about the idea behind zeros and ones. If you're taking computer science, you might have gotten some access to that. But we will be eventually talking about numbering systems. I was going to cover numbering systems before we got here, but I figured we probably push that off. I have that planned as the next unit after we've done this, and so zeros and ones, yeses and nos is basically what we're going to say. So yes, there is, or no, there isn't. One represents there is a connection. Zeros representing there's not. Okay, I think. Are we good on here? Does anybody need more time on here? And just some definitions. It's probably better for you to see this in practice. So in this question B, I'm gonna describe the network graph. Sometimes I like to write the word network just to remind you, where I just don't say graph, because most people think graph X and Y. And we need to understand that there's other types of graphs. Using adjacency, can't spell that. Using an adjacency matrix. So the way we do this is kind of like using a table. Basically, it's a table for our purposes and how we're going to be viewing it in our course. All right, so it looks like a table, and the table always has it's n plus 1 rows and columns, where n represents the number of vertices. So how many vertices do I have in this problem right here? How many vertices are there?
It is 4.
How many? 5. There's 5 vertices. A, B, C, D, E. Okay. So there's 5 vertices. So we're going to make sure that, well, I guess I said that's how many lines we're going to end up drawing that are going to break them up, basically. Because, so, yeah, so that's going to put me how many columns, but because there's always going to be one column that's going to be left blank, as you'll see. So 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Okay. Now, sometimes what we can do is when we draw these, when you might see some of them, for example, where we get rid of that we get rid of like kind of the top and the bottom right here, and you might see them just like this. It works very much the same. I just closed it off. That's how I've drawn them for you, so we can have them either way. We'll just leave it like that. And what we do here, first and foremost, this top left one is just left blank. Okay, so you don't do anything in here. You don't even have to color it in, but we just leave that blank right there. There's nothing in there, and we list the vertices. Okay, so our vertices are labeled and named A, B, C, D, and E. A, B, C, D, and E. Now, for our purposes in here, or what we have on these ones, is that A is not connected to itself. There are things called loops, which which I will introduce next week as well. But right now, A is not connected. Each of these is not connected to itself. So in the vertical or in the diagonal, we're going to have zeros here because A does not connect to A, B does not connect to B, C does not connect to C, D does not connect to D, and E does not connect to E. Eventually what we'll see is we'll get things like this that are called a loop. And so A will talk to itself. And there's certain applications that can be something that's helpful for us, where A sends things out to B, C, D, but it also sends things back to its own self. That will occur, but for now they are not. So we have that a node, a vertice is not adjacent to itself. So okay, so if everything is just left to left or right, so we say that here there's no connection between A and A, B and B, C and C, D and D, E and E. That's why they're all zeros right there. So there's no edge between those. Now let's talk about edge B. And for now, like I said, we don't have to worry about directed yet. So I don't want to define it for you yet because we're just still learning. But we have now the edge BA. Is B connected to A? So now, well, actually, let me highlight these one at a time. All right. So let's talk about this edge right here, A to B. All right. So we're gonna find A to B, which is right here and right here. So we put a 1 on both of those. For now, we're talking about it because we want to make sure that there's a connection. And this just notes that it's undirected, that A talks to B and B talks to A. All right. My next edge, AD. So AD, there's a 1 right there. And AD, 1 right there. So that's what I said about it being mirrored. It's mirrored like if you're folding it on that diagonal. Next one, AE. Okay. So I like to go left to right first. So AE right there. And then AE right there. AEEA. Or if you want to say it both ones, if you just I usually, you can just say, AE and then EA. So they're both the same thing, AE and EA. My next one, CD. So CD and DC. And finally, CE is right there, which is EC, which is right there. What is everything else?
Zeros.
Zeros. There's no connections between the others.
So what we do, we put a 1 on the box that represent the edges.
Correct, that's it.
Ooh, okay, get it.
And remember, we read them both ways. So we read them as AB and BA. So we refer to these as the rows and these as the columns. And we always read it as row by column. So when we say AB and BA are the same thing, that's the row A, column B, and row B, column A. Now, this is actually what we're going to use next week. That's how we use directed. So when referring to, both of these actions, I don't want to use that. This is AB. So when we say AB with the brace, we're referring to AB and BA when we read these as row columns. So when we talk about matrices, we always do row columns. And that'll be more important when we talk about directed graphs, but for now it's A, B, B, A. So if you don't, understanding which ones are rows and which ones are columns, and that I do want to preview that for you, but you just basically find the as was said, the box, that is between A and B, and there's always two of them. There's one that's in the row in the column, and one that's the column in the row. Okay. So one more example. Okay. And I'm gonna, I guess, V1, V2, V3, V4. And we'll leave it right here. And we're going to describe using an adjacency matrix. And in your homework, I didn't write the word adjacency, but when I say describe as a matrix, that's what we're doing. They're always adjacency matrices. Okay. So, how many vertices are there?
4.
4. So I'm gonna go 1, 2, 3, 4. So depending on how you're drawing, and then 1, 2, 3, 4. I'm going to label them as they are. So V1, V2, V3, V4, V1, V2, V3, V4. And then I know there are no loops. And for now, these are always going to be zeros in all your homeworks. That diagonal line right there will always be zeros. And then we go through each one. So I got V1 and V3. All right. So row, column. So V1 in my row, V3 in my column, and V3 in my row, or V1 in my column and column row, which is right here. V1, V3, and V3, V1. I write them. I indicate them both ways. V2, V4. V2, V4 is right here, and V4, V2 is right there. And V3, V4 with V4, V3, and everything else stays or returns to a 0. That's what I have for you. Your homework is on Google Classroom. You have just under 20 minutes. I think that's more than enough time to be able to complete the homework. I've actually even drawn the tables for you. You really just have to indicate the zeros and ones into the table. So I didn't want to have you to worry about having to create the tables and so forth. If you have any more additional questions, I'm still around. If not, that's the end of our lecture.